Hello everyone, and welcome to
Fundamental Science!
Today, I would like to invite you to participate in an experiment I like to call Magic Water Density Experiment. The purpose of the experiment is to determine if two jars containing warm colored water and cold colored water will mix when placed open-end, one on top of the other. To perform the experiment, you will need the following: two jars, warm tap water, cold tap water, food coloring, and transparency film. The procedure is as follows. Pour warm tap water all the way to the brim of the first jar. Now, pour cold tap water all the way to the brim of the second jar. To the first jar containing warm tap water, add a few drops of blue food coloring. The second jar containing cold tap water, add a few drops of yellow food coloring.
A few moments later.
Now, place a small piece of transparency film to the open end of jar 1. Very carefully flip the jar upside down, making sure that the blue colored water does not spill. Place the jar on top of the second jar containing yellow colored water. And now observe what happens. So what exactly is happening? Why are the liquids in the jars mixing? Why is the yellow colored water on the bottom moving upward to the jar with the blue colored water? The experiment works because of the different densities of hot and cold water. So what is density? Well, density in basic terms means the weight of a certain material in a particular volume. So picture an empty plastic pop bottle. If you were to fill it up with water, it would have a certain density. However, if you were to fill it up with tiny rocks, it would have another density. The density of the pop bottle filled with rocks would be greater than the bottle filled with water. That's because rocks are heavier than water in a particular volume. In this case, same size pop bottles. But water has the same density. So why does it stay separated, but over time it begins to mix? The secret is in the temperature of the water. Warm water particles have more energy than cold water particles. The tiny water particles want to move around faster, bounce around, leave gaps, and therefore want to rise to the top and escape. Cold water particles have less energy than warm water particles. The tiny water particles do not want to move around and therefore stay close to the bottom. Therefore, hot water particles are less dense than cold water particles. So when you put the cold water on the bottom, the dense cold water stays there. However, over time, when the cold water warms up and the hot water cools down, the two begin to mix. The cold water, as it warms up, gains energy, and the hot water, as it cools down, loses energy. If you enjoyed this video, give it a thumbs up and subscribe. Thank you for watching, and see you next time.